Hi, this is Victor Morganti from Fact Engine. This video is going to make object role modeling very easy for people to understand, especially for newcomers to object role modeling. We're going to have a look at object role modeling through the eyes of the Boston conceptual modeling software, which specializes in object role modeling, but it also specializes in entity relationship diagrams and property graph schema. So what we're going to do is show how object role modeling relates to entity relationship diagrams and property graph schema, while at the same time introducing the key concepts of object role modeling. We've got a model open in the Model Explorer, which we've called the ORM Made Easy Mastering Object Role Modeling Model, and we've got one page in the model. I'm going to open that page. I've called it an ORM page because it's an object role model page, and at the moment it's blank. We're going to fill that out with an object role model. To make things easy for everyone, what I'm going to do is add a entity relationship diagram to the model, and we'll call that the ERD page, and we're also going to add a property graph schema page as well. And we're going to call that the PGS page. So we've got three pages. Let's open the entity relationship diagram view and the property graph schema view. We're going to go back to the object role model page, and we don't really need the Model Explorer anymore, so I'm just going to hide that so we've got more room on the canvas. So inside Boston we can work on multiple pages at the same time. So what I'm also going to do now is open three pages. So the object role model, the entity relationship diagram page, and the property graph schema page, all at the same time. Now I'm going to right click on the ORM page and go to the toolbox, and we can see the various model element types that we can have in object role modeling. So entity types, value types, roles, fact types, subtypes, and then various constraint types. So ring, external, equality, external uniqueness, equality, exclusion, inclusive or, subset, frequency, and value comparison constraints. Now what I'm going to do is start with an entity type that we're all familiar with, and that's an entity type of person. Now something that's new people to object role modeling find difficult to understand from the get-go is that entity types need a reference scheme. So this entity type person is coloured red, and if I go to the error list we can see that entity type requires reference scheme error for the entity type person. So why is that in error? Well, let's go to the let's open the model dictionary for the entity relationship diagram view. Now sure enough we've got an entity person. Now I might get a warning when I drop that on the page. No warning. But a entity type without a reference scheme is like having an entity in an entity relationship diagram without any columns or attributes or fields. So we know in the relational model that every entity in an entity relationship diagram must at least have a primary key. So let's do that. Let's go to our person entity type, go to its properties, and there's two types of reference scheme. You can have a simple and a compound or complex reference scheme. We're just going to give it a simple reference scheme by setting its reference mode, and we're going to set the reference mode to .id. Now you can see straight away that we've added a person ID column to our entity relationship diagram, and it's the hash says that it's a primary key and the star says that it's mandatory. If we click on person and have a look at it, verbalization, we can see that person is an entity type and the reference scheme is person has person ID. That means that that's the unique person ID, or the relationship person has person ID, uniquely identifies a person. Now, if I go to the properties, and there should be something there to show the reference mode. Here we are, hide reference mode. So that's set to true. I'm going to set that to false. And now you can see the reference scheme on person ID. And so that's the reference mode is .id. And in object role modeling, if I expand the reference scheme, in this case the reference mode, we can see that we have a fact type, this is called, and where person has person ID and person ID is of person. So this is called a fact type reading. Person has person ID is a fact type reading, and person ID is of person is a fact type reading as well. The dot says that it's mandatory, so as per our entity relationship diagram we can see that the that column is mandatory, and these are internal uniqueness constraints. I'll describe those as we go forward, but internal uniqueness constraints determine the cardinality and the uniqueness of instances underneath our fact type. The double bar says that this particular uniqueness constraint determines the primary reference scheme for person. So the primary way that person is uniquely identified is by person ID. So let's hide that now, and we can see that we have person with a reference scheme of ID that's uniquely identified by SD, a person ID. And if I go to the property graph schema view, that of course relates to a node type, and if I control click I can see that there's a person ID property against person. Now let's have a look at fact types and internal uniqueness constraints. So we're going to open the toolbox again, and firstly what we're going to do is going to create a value type and call that login name. So we've got person and login name. Now a value type ranges over a set of values. So you can imagine where people in our universal discourse have login names, and the login name value type ranges over a range of values, which are login names. Now we want to start a relationship between person and login name. So if we go back to the toolbox and drag a binary fact type, here's a binary fact type, and drag one role to person and one role to login name, we've started to set up our fact type. Now what we want to say is that every person has a unique login name, and a login name is unique to person. Now in terms of making object role modeling easy, there are various patterns that you can learn which make it very easy to understand object role modeling. Whenever you see a value type, it's always going to be a column somewhere, or form part of the name of a column somewhere in a entity in an entity relationship diagram view, or a property in our property graph schema. Now I'll show you the first pattern first. What we'll do before we do that is we'll give this what's known as a fact type reading. I've selected that fact type, which at the moment is called new fact type. We want to give that a reading, so person has login name. So that's fairly easy. And Boston asks us, will I change the fact type's name to person has login name? That's convenient, so I'm going to say yes to that. And we've given a forward reading fact type reading for this particular fact type. So person has login name. Now I'm going to add a uniqueness constraint, an internal uniqueness constraint. So I click and add a uniqueness constraint to that role. And watch what happens. So we've said a person has a login name, and this pattern here always forms a column in our entity relationship diagram view. So we've created a column called login name, and that little O there means that it's not mandatory at this stage. So we're saying that a person appears in this particular fact type uniquely for login name, and we can test that by looking at what's known as a fact table and sample populations for that fact type. So let's have a look at that. So this is a fact table, and we're going to add a row to our fact table, and we're going to say that we have a person ID of 1 and we have a login name of Peter. That's fine. We've said that a person can have a login name. What does this internal uniqueness constraint say? Well, let's add another row, and let's say we have a second person with a login name of Paul. You can see that these two values are red because there's an error there. I might be able to see what that error is, and it says a population uniqueness error. Multiple facts violate the internal uniqueness constraint, internal uniqueness constraint 3, and values include 1. That's because we've said that this value needs to be unique in this particular instance, and we've created a duplicate, so we're going to have an error. So let's change that to 2, and now we're okay. So person 1 has login name Peter, and person 2 has login name Paul. Let's create a third row, and let's say that person 3 has login name Peter. Now, we don't necessarily want that to be true. We want people to have unique login names within our universe of discourse. The way we would do that is put a uniqueness constraint also over this particular role, and when we do that, we can see that Peter and Peter is red because we've said that we have a one-to-one relationship, and this pattern here is a one-to-one relationship. So whenever you see a binary fact type with 2 internal uniqueness constraints like this, that means it's a one-to-one relationship. So that's a pattern that you can learn, and that also creates an index on our entity type or entity within our entity relationship diagram. So let's fix this and call the third person Kathy. And I think if I refresh my error list, that then goes away, the error. So person 1 is Peter, person 2 is Paul, person 3 is Kathy. This pattern here says that we have a one-to-one relationship between person and login name. Now I want to make every person that it's mandatory that they have a login name, so I'm just going to say mandatory, and now you can see that the login name field on this particular entity type, our entity in our entity relationship diagrams, has a star, which means it's mandatory. If we look at the indexes for that particular entity type, we should see a unique index for login name. We do. So if I click on the person UC, which is a uniqueness constraint, it says unique here as the type. It's against login name. The primary key, so person PK1, and the type is primary, is against person ID. So effectively, by setting the reference mode, we've created a primary key, and by setting the a one-to-one relationship, we've set a unique key for login name. Now let's dispel a myth about object role modeling. It's quite often said that object role modeling has no concept of attributes, that it's attribute free. Well, to my mind, and I wrote the Boston conceptual modeling software, and I've got 30 years experience with object role modeling, it's a bit of a misnomer to say that object role modeling is attribute free. This type of fact type creates an attribute within a corresponding entity relationship diagram. So these values, or this structure, within a object role modeling definitely defines attributes within a property graph entity relationship diagram view. Or if I control click on person, I can see that it's created properties within my property graph schema view. What's also said of object role modeling is that it provides semantic stability, and we'll talk more about that. But what that's hinting at is that by having this fact type here, which effectively creates our attribute or our property, we are doing two things. We're setting up our uniqueness constraints, that's fine, and we're saying things are mandatory or not, that's fine. But we're also providing a semantic layer or a semantic view over the top of our entity relationship diagram. So if this was a database and we had a person table and login name, this is a very simplistic fact type reading, but we know that person has a login name. The beautiful thing about object role modeling is that because we use natural language and provide semantic information that can be used to allow us to do semantic analysis of conceptual models or ontologies, is that we can use natural language to create the model as well. Let's hide this fact table. I'm going to click on this form so that I know that I'm adding to it. I'm going to go to the virtual analyst in Boston, and I'm going to create a new entity type. So I'm going to say film is an entity type. So we're going to create a database for people making bookings to watch films at a cinema. So let's say film is an entity type, and when I hit space on that, we can see that it's color coded now, so Boston understands that, the virtual analyst understands that. I'm going to hit enter, and the virtual analyst is a conversational user interface into Boston for creating object role models. So it said you said film is an entity type, and it said don't forget to give the entity type a primary reference scheme as soon as possible. And the virtual analyst is Brianna, and Brianna says okay. So Brianna's understood that. She's created a film entity type. It's red because it hasn't got a reference scheme, and we just learned about reference schemes. So let's say film is identified by its ID. So we're going to give film a film ID the same as person. So I've hit space and it understands that. It's color coded it for us. You can hit OK. Now Brianna has created the reference scheme. We can go to our properties. We know that we can unhide the reference scheme so we can see it if we want to. So now we have film and person. So if I go to my entity relationship diagram view, go to its model dictionary, we now have a film entity which has a film ID. And if I click on the property graph schema view, I can go to the model dictionary and grab a film node type. So we want our film to have a film name, so let's add that quickly. So we're going to say in the virtual analyst, film has one film name. Now what that's going to do is create two things or three things at the same time. or four things. It's going to create the value type, the fact type, the mandatory role constraint, and the internal uniqueness constraint all in one go. So I'm going to hit go on that, and so Brianna says, would you like me to create a value type for film name? I'm going to say yes. And would you like to create a fact type? Film has film name, yes. And it's automatically put the uniqueness constraint and the mandatory role constraint against film has film name. So we can see we've added film name as an attribute in film, and if I control click on my node type, I can see film name as a property on my property graph schema view. Similarly, for person, we want film name to be unique for films, so I'm going to add a internal uniqueness constraint against that role. And now we've set up, we've learnt this pattern here. We've set up a one-to-one relationship between film and film name, and if I go to the entity relationship diagram view, for instance, and look at the index manager for film, I can see I've got a primary key of film ID and a uniqueness constraint on film name. So this pattern here is a one-to-one relationship. We've learned that whenever we have a value type, invariably somewhere in our database that's going to appear as a column name or part of a column name and a property within our property graph schema view. Let's have a look at another pattern now. I'm going to say, move that, say, over here. I'm going to rearrange this just a little bit just to give us more room to play with, because this diagram is going to get a little bit busy. I'm going to save the model now just so that we can feel secure that it's saved. Now I'm going to say person has at most one age. Now this is fact engine knowledge language that we're using to define our object role model. At most one says that we're going to put a internal uniqueness constraint on our fact type, but we're not going to make it mandatory. So I'm going to hit go on that, and Brianna says, would you like me to create a value type for age? We'll say yes. And would you like to create a fact type, person has age? Yes. And now Brianna's gone away and created for us a value type age, a binary fact type. So this is known as a binary fact type with two roles. These boxes are known as roles, and a uniqueness constraint that the role is not mandatory, where we've set up person has age, and we can see where we have a non-mandatory attribute added to our entity relationship diagram. And if I refresh this node type, we can see that person has an age in our property graph schema view. Now when you see this type of binary fact type with a single uniqueness constraint, there's a way of looking at it which makes things very easy. We can say that this is a many to one relationship, and we'll test that by saying, show me the fact table, and we'll add a row to it, and we know that we've got a person 1, and we're going to say that Peter is 21 years old, and we're also going to say that Kathy, I believe her name was, is 42 years old. And we want to show that we've got a many to one, so we'll say that Paul, so person number 2, is also 21 years old. Now we don't have any errors there, nothing's red, because we've got a many to one relationship by this pattern here, where we've got two people, Peter and Paul, so 1 and 2. So 1 and 2 are the unique IDs of people in our universe of discourse, and two people have the age 21. So you can read it the other way around as well. So one age can have many people. So the age 21 has many people within this fact type, because we've set up a many-to-one or a one-to-many relationship. So that's another pattern that you can learn quite easily. I'm going to hide that fact type, bring this down here so that we've got a bit more room. I'm going to save the model. So we've looked at binary relationships, and we've looked at many-to-one binary fact types that are set up by this pattern, and we've seen a one-to-one binary fact type set up by this pattern here. Let's have a look at a many-to-many relationship. So let's create a fact type, person likes film. So I'm going to hit go on that, and Brianna's going to analyze that and say, would you like me to create a fact type, person likes film? Yes. And then Brianna asked me, what sort of cardinality do you want over the values that fill the roles of that fact type? At most 1, 1, or many to many. Let's say many to many. And now we have a couple of things happening at the same time. We've got a uniqueness constraint which straddles all of the roles of this fact type. And because it straddles more than one role, we've set up a many-to-many relationship between person and film. So a person can like many films, and a film can be liked by many people. So when you see this pattern, it's a many-to-many relationship. We understand what's going on there when we look at the entity relationship diagram view. We've automatically created a person likes film entity, and it's a many-to-many join table, and where it uniquely joins to person and film. So person and film, and it's done that for two reasons. One is because we've set up this many-to-many relationship, but we've also done something special. We've objectified or nested this fact type. So you can see it's got a blue line around it as if it were a entity type, and that's effectively what we've done. We've created an entity which sets up a many-to-many relationship. It's got a multi-column primary key against person and film, and we've also set up a many-to-many relationship within our property graph schema view, where person likes film, and we can add a reciprocal reading. So let's do that. So this is called a reciprocal reading. We're going to say film is liked by person, and now if I go to my property graph schema view and click on that relationship, we can see two readings, so likes and is liked by. So person likes film, and film is liked by person. There's a bit going on there, so let's recap. What we've set up is a binary fact type, so it's got two roles with a uniqueness constraint across multiple roles, setting up a many-to-many relationship. And we've got a forward reading, person likes film, and we've got a reciprocal reading, film is liked by person, and we've objectified, or we've nested, the fact type to ostensibly turn it into a entity type and an entity within our entity relationship diagram view, and it becomes a edge type in our property graph schema view. Now we're going to look at ternary relationships or ternary associations or ternary fact types. To do that, firstly I'm just going to quickly create another entity type. I'm going to call that cinema. So I'm going to say cinema is an entity type, and that's been added to my model. And I'm going to say cinema has one cinema name. Hit go on that. Brianna's going to say, do you want to set up a value type for cinema name? Yes. A fact type for cinema has cinema name? Yes. And because we've said one, we know that cinema has one cinema name. So I'm going to put that right up the top here. We haven't set up a reference mode for cinema, so I'm going to do that over here in the properties. I'm going to say cinema has a cinema ID, and if I look at my entity relationship diagram view, I've set up a entity cinema with a primary key of cinema ID and a mandatory cinema name. Once again, I'm going to set up a one-to-one relationship, so a unique index on cinema, and we have cinema has a cinema name, and that's a unique index. If we go to our entity relationship diagram view, have a look at the index manager, we've got a primary key of cinema ID and a unique index on cinema name. Now let's create a ternary fact type. First of all, I'm going to add another value type to our universe of discourse, and I'm going to call that date time. And in this instance, I'm going to give date time a data type in our database, and it's going to be temporal, date and time. Okay, so if we have a cinema bookings universe of discourse and want to create a database for cinema bookings, we'll have sessions for films at a cinema. So let's create a ternary fact type between film, date, time and cinema, so we can go and watch a film at a date, time at a cinema. I'm going to do that quickly in Boston by clicking on the film entity type, control clicking on date, time, and control clicking on cinema, and just pressing the R key, which will set up a relationship between all three of those, so an association. And now we've got a ternary fact type. So it's got three roles. It's red because we haven't got a fact type reading. Every fact type needs a fact type reading, and it doesn't have any internal uniqueness constraint. We know that we want this to be a many to many to many relationship, so that a cinema at a particular date and time can be showing more than one film, or a film can be shown at the same date time at many cinemas, or on a particular date and time we can be showing multiple films at multiple cinemas. It's a many to many to many relationship. So let's click on the first role, control click on the second, control click on the third, right click and add a uniqueness constraint, and that's going to automatically objectify that for us. So we've got a internal uniqueness constraint across multiple roles, setting up a many to many to many relationship, and let's add a fact type reading for that. So I'm going to say film on date time is showing at cinema, and I'm not going to change its name to a long name like that. I'm going to just leave it like that for now. So we've got film on date time is showing at cinema. We can have multiple readings, so I can say cinema is showing film on date time. And of course we know we can fill out the Cartesian product of all possible fact type readings, and you can even have multiple fact type readings for the same sequence of object types within the the fact type. So that's no longer showing red, it's not in error. It didn't objectify it, so let's objectify it. So I'm right clicking on the fact type and I'm saying objectify the fact type. So now it's got a blue line around it as if it were an entity type, and we can see that we've created a film, date, time, cinema it's a many-to-many table, but it's got a primary key across 3 columns: film, date, time, and cinema. We don't particularly like this this name, so let's change the name. I'm going to click on the entity type, go to its properties, and I'm going to change its name to session. And what I'm going to do is right click and I'm going to say show the fact type's name. So we're saying that a session is a combination of film, date, time, and cinema. So we can book a session to watch a film at a date, time, at a cinema. So let's create a booking now, and we're getting the gist of it. So let's control click on that objectified fact type, control click on person, hit the R key, and we're going to set up a many-to-many relationship between person and session. So a person can book many sessions and a session can be booked by many people. We're going to add an internal uniqueness constraint across both those roles to set up a many-to-many relationship. So this pattern is for a many-to-many relationship. We're going to give that a fact type reading, so person booked session. And we won't change its name to the suggested one. We're going to click on it. Let's objectify it. Give it a name of booking. And show the fact type's name. So now we've set up an entity type, objectified fact type, which has a corresponding objectifying entity type, booking, and where person booked a session. Now when I add that to the entity relationship diagram view, if I add booking here, we can see the booking entity. There should be a foreign key reference to session. I'll pause the video in a second and see if I can fix that. But we don't particularly like this predicate that person is involved in booking and booking involves person. While that's true, we can make that a lot easier to read by having a look at an advanced concept in object role modeling, which is if we click on that role within booking and view what's known as a link fact type, which applies to roles that are in objectified fact types, we can see that we have an implied fact type. Person is involved in booking and booking involves person, which is the same as our predicates here. Person is involved in booking and booking involves person. Let's click on that and change the fact type reading. So I'm going to say booking was made by person. Hit go on that. I'm not going to change the name of the fact type, and I'm going to change person is involved in booking to person made booking. Now when we look at our entity relationship diagram, we can see that person made booking, and this should read person booking was made by person. Let me just see if I can fix that up, and I'll come back. Okay, we've fixed that. So now when we look at this relationship between booking and person, we can see that booking was made by person and person made booking. And of course we just learned that we have, for objectified fact types, link fact types that are for the roles. A link fact type is an implied fact type, and where we're saying that a booking was made by a person and where a person made a booking. And a link fact type has dashed role bound borders. So the borders of the roles in a link fact type is dashed, and they are an implied fact type, and that's how we get our predicates for our foreign key relationship in our entity relationship diagram view. And also we'll recognize this pattern where we're saying there's a many-to-one relationship between booking and person. So a person can make many bookings, and that's what we want. So a person can make many bookings to go to a session, to watch a film at a cinema. So the overall relationship is a many-to-many relationship between person and session, and that's internal uniqueness constrained across these two roles. But the relationship between person and booking itself is a one-to-many, or reading this way, a many-to-one relationship. And it's the same between booking and session. So let's set up the predicates for the link fact type between booking and session. So if I go booking and change that for is for session, so I am going to change the name of that, and I'm going to say session has booking. And that might be difficult to read there. Here we go. So a booking is for a session, and a session has a booking. So that reads more in natural language now, and that's how object role modeling helps you form a semantic view over the top of your relational, your graph database, where we're saying a booking is for a session and a session has a booking. Let's add some node types to our property graph schema view so that it starts to fill out now. I'm going to put person down here, I'm going to put film up there, and where I'm going to put a cinema there, and it's automatically loaded the session relationship, and where I can probably put booking on the... No, let's remove that. Let me just have a quick look at that, I'll get back to you. Okay, so we've just added booking to our property graph schema view. So booking was made by person, a person likes a film is liked by a person, and film is showing on date time at a cinema, and that's our session. Now I should be able to display that as a node type, so I'm going to do that, which should make life a lot easier for us. So we're going to do a couple of things now to make this look more like a property graph schema that we're all used to, and we're going to do that by looking at link fact types. So I'm going to open the link fact type, and I can do that because this objectified fact type is a fact type that's objectified, and I'm going to say that a session is to watch film, and yep, I'm going to change the name, and going to say film is showing at session. And what I should be able to do is set the properties of that and change its DB name. Just had to reload that page. So we're saying session is to watch film. And if I click on it, we can see that a film is showing at session, so the reciprocal reading. I can make it look more like a traditional property graph schema. If I click on it and in its properties change its DB name to session is for in capital letters. Just had to make a quick change to my configuration to set it up to show edge labels more like a property graph schema that you would see perhaps for, say, Neo4j or something. So now we've created an edge label is for, but if I click on it I can still see the object role modeling predicates. Film is shown at session, and session is showing film. And see, session is to watch film and film is showing at session. We can do let's do the same for session and cinema. So session is at cinema, and now we've got a traditional property graph schema view where we're saying session is at cinema, or if we click on that we've got involves and is involved in. Let's change that. So session is at cinema, and we're going to say yes, change that, and cinema, and we're going to say is hosting. So now when I click on that I should see now when I click at that I can see session is at cinema and cinema is hosting session. Similarly for booking and session, let's change that for booking is for session, and booking I'm going to say was made by person, and we're going to change that edge type label to likes. So person likes film. So now that looks more like a traditional property graph schema view. So our model's starting to fill out. Let's have a recap of what we've learnt so far. So we've learnt that this pattern here defines a many to one relationship where many bookings can be for the same person and a person can make many bookings. We've seen that this pattern here with a uniqueness constraint across multiple roles is a many-to-many relationship. So we're saying a person can like many films and a film can be liked by many people. And across a ternary fact type, we have a many-to-many-to-many relationship where a film can be showing on many dates at the same cinema or at multiple cinemas. It's a many-to-many-to-many relationship. This is a ternary fact type. Once we get above 3, we generally say n-ary. So a binary fact type, a ternary fact type, and if we had 4 or more, we would say an n-ary fact type. There is such a thing as a unary fact type, where a fact type only has one role. And if I want to set one up for, say, person, let's go back to our virtual analyst and say person has season pass, or season ticket. Let's say we sold a thing called a season ticket, and we wanted to store that in the database, and we'll hit go on that. Brianna says, would you like me to create a fact type? Person has season ticket. We'll say yes. I wasn't focused on the object role model page, but I'll drag that unary fact type over here now, and here's our unary. So let's recap just one more time. So we've got a many-to-many-to-many relationship across this fact type. It's objectified, so it becomes an entity in our entity relationship diagram view, or a node type in our property graph schema view. We've seen that this relationship up here, where we've got a binary fact type with a one-to-one relationship established by internal uniqueness constraints, sets up an index on our entity relationship diagram view. So if I look at the index manager, we can see that there's a uniqueness constraint against cinema name. We can see that same index for our property graph schema view as well. So cinema uniqueness constraint is on cinema name, and we've seen where a objectified fact type, for its roles, we can have link fact types which help us establish our predicates in our property graph schema view and our entity relationship diagram view. So if I click on this link fact type, you'll see the role that it applies to. So that's the purple role in the booking objectified fact type. And if I click on this link fact type, you'll see the other role turning purple as I click on it. So the role has an implied link fact type between booking and session, where booking is for a session and a session has a booking, and where booking was made by person and person made booking. Again, clicking on it, this is an implied fact type. It's called a link fact type, and it's for this role here. Now let's have a look at some other concepts in object role modeling and how they relate to entity relationship diagrams and property graph schema. We'll be looking now at some of the other types of constraint that are used in object role modeling. I'm going to go to the virtual analyst and say that a row is a entity type. Before I do that, I'm going to click on my object role model so it throws it up there. And we've just created row. And I'm going to say that a row is in a cinema. Row is in cinema. And I'm going to say a row is in one cinema, just to speed things up there. Brianna says, would you like me to create the fact type? Yes, please. So now we have a fact type, row is in cinema. It's mandatory that a row is in a cinema. So you can imagine seats in rows in cinemas. And we know this pattern here is a many-to-one relationship between row and cinema. So a cinema can have many rows. And it's red because it hasn't got a reference scheme. So that would be the same as if we go to our entity relationship diagram view, having a entity type or an entity or a table in a relational database without a primary key. Now we're going to set up a multi-column primary key, and the way we're going to do that is we're going to say that a row has one row number, and we're going to set up a value type for row number, and a fact type for row has row number. Here's our fact type. Now in a cinema, because our database has multiple cinemas, a row is uniquely identified by its row number, but because we want multiple cinemas in our database, we want to say that a row is uniquely identified by the row number and the cinema number within our tables in our relational database. Now to do that, we'll set up what's known as a external uniqueness constraint. So that's this round circle with a bar through it, and drag to a link to the role that joins to cinema, and drag a link to the role that joins row number. Now I have a uniqueness constraint across cinema and row number, but it hasn't changed to a primary key yet. The way I'll do that is by going to the properties of the external uniqueness constraint and setting it up as the preferred identifier. So I'm going to change from false to true. Now notice that we have a double bar there now, and a double bar means that it's the primary reference scheme for row. So rows are uniquely identified by the cinema that they're in and the row number that they're in, and that's determined by this external uniqueness constraint. The double bar means that it's the primary identifier for a row. And if we look at our row table or our entity now, we have a primary key indicated by these hash signs across cinema and row number. So we're happy with that. Let's add row to our property graph schema. And our database is starting to come together. Just going to save the model. I'm going to do the same sort of thing for a seat. So let's set up seats in our cinema. So let's go seat is an entity type. That's pretty easy. That's created it over here. We also want to add it to our property graphs object role model, sorry. And let's add it to our entity relationship diagram view. Now notice the entity doesn't have any columns yet because seat is red here, and that means it hasn't got a primary reference scheme, and we'll set that up. But firstly I want to say that a seat is in one row within a cinema, and we'll say yes to that. And you'll know that when you go to a cinema, a seat has a letter. So we can go to seat number A in row number 1, for instance. So let's say seat has 1 letter, and we're going to set up a value type for letter and a fact type for seat has letter. And we still have a red entity type because we haven't set up a primary reference scheme. So let's go to the toolbox, grab an external uniqueness constraint, because we're going to set up a multi-part primary key, so multi-column primary key. We're going to drag a link from the external uniqueness constraint to row and to letter. I'm going to right click on the external uniqueness constraint and set it to being the preferred identifier. And we can see that straight away now our seat has a multi-column primary key across 3 columns: cinema ID, row number and letter. So we can have a cinema with a cinema name, say the Rialto. The Rialto in row number 1 has seats letters A, B, C, D, E, F, G, etc. And it's a many to many to many primary key, so a compound or composite primary key across 3 columns. Interestingly, our external uniqueness constraint only has 2 links, but that's okay because this link here draws its information from the primary reference scheme for row, which is across cinema ID and row number. So when we get down to our seat, the external uniqueness constraint sets up cinema ID, row number and letter as the primary key for seat. Now this should turn blue, so everything's okay there. Now just to finish off our database, we're going to say that a booking is for 1 or more seats, and where a seat can have more than 1 booking. So I'm going to click on booking, click on seat, hit R to set up a relationship between them. We want to set up a many-to-many relationship, so we know we need a internal uniqueness constraint against both roles. And I'm going to objectify that fact type, and I'm going to give it a reading because we know a fact type needs a reading. So we're going to say booking has a seat and I'm going to say a seat has a booking. Yep, seat has a booking, and we can see that we've set up the forward reading and the reciprocal reading for booking has seat. Now I'm going to change that to booking has seat, just the name of it, and we can show the fact type name if we want to for that. So booking has seat. So that's our object role model. If we go to the model dictionary, we can drag the many-to-many table across between booking and seat. So this is a many-to-many join table. Now it has 1, 2, 3, 4, 5, 6, 7 columns in the primary key, even though we've only just joined 2 object types in our object role model. That's automatically translated to us as a multi-part primary key in our entity relationship diagrams. So the object role model automatically transforms to the corresponding entity relationship diagram, and if you noticed, we've also created this relationship here between this edge type between booking and seat. So if we go to the properties, we can say give that a label of has, and we're going to change this to is in. So a seat is in a row, and where a row is in a cinema. So we're well progressed with our object role model, and just to close out, I'll set up an advanced concept of object role modeling to give you an idea of the power of object role modeling. With our model, and let's have a look at the property graph schema view. If a person makes a booking for a seat, we want to make sure that our booking is for a session that's at a cinema where that seat is in a row that's in that same cinema. There should be a link between booking and session here. Just give me 1 sec, I'll fix that up. So I've just fixed up that link that was missing. So booking is for session, and booking is for session here. And what we're going to do now is we're going to add a join subset constraint, which is a type of constraint that's quite powerful inside object role modeling. This is quite an advanced topic, but it gives you a feel for the power of object role modeling. So I'm just going to drag a subset constraint onto this page, and then I'm going to say if some booking has some seat, then that booking is for some session that is at some cinema that contains a row that contains that seat. So now when I click on that join subset constraint, it's called a join subset constraint because we joined a whole lot of roles in what's known as a role or a join path, and we can go to its reading. So if some booking has some seat, then that booking is for some session that is at some cinema that contains some row. And I'll just make a quick change here so we can read it a bit easier. And I'm going to say row contains seat, and click on it again just so it reads a bit clearer. If some booking has some seat, then that booking is for some session that is at some cinema that contains some row that contains that seat. So in the object role model that's quite busy, but what we've set up, I'll just save that, is we've said that if some booking, if we're looking at the property graph schema view now, if some booking has some seat, then we would want to make sure that that booking is for a session that's at a cinema that has a row that contains that seat. So we don't want to make a booking for a seat that's actually at a different cinema. So we're saying that if some booking has some seat, then that booking is for some session that is at some cinema that contains some row that contains that seat. So let's click on the join subset constraint again and read the reading again. If some booking has some seat, then that booking is for some session that is at some cinema that contains some row that contains that seat. So that's a very powerful constraint, and that gives you an idea of the sort of constraints you can have in object role modeling. So thank you very much for watching. I hope you enjoyed the video. If you'd like to learn more about object role modeling, please see my Udemy course, so Mastering Object Role Modeling. It's available now on Udemy, and you can send me any messages there if you have any questions about object role modeling. I'll be happy to answer them. Thanks for watching. Talk to you soon. Thank you for watching. I hope you enjoyed the video. I'm Victor Morgani from FactEngine. FactEngine provides consulting on knowledge graphs, object role modeling, property graph schemas, and relational models. And of course, FactEngine is the author of the world-leading Boston conceptual modeling software. Thanks again. I look forward to speaking with you soon.